For the first time, scientists have spotted a bizarre X particle in a recreation of the primordial soup that existed just moments after the Big Bang. By smashing billions of lead ions together using the Large Hadron Collider, researchers were able to find just about 100 of these mysterious particles. But that could be the start of figuring out exactly what this X particle is made of. That's why it's just called the X particle. It's not like it broke up with a physicist or something. There are a few different ideas on what it could be, but no one is sure yet. And figuring it out could tell us more about what the universe was like a split second after it formed, and help us better understand the protons and neutrons that make up the nuclei of atoms. You know, life's little questions. To understand this mystery, we're gonna have to talk about fundamental particles called quarks. Don't panic, it'll be easy. Breathe. Some particles, like protons and neutrons, are made up of 3 quarks. It's also possible to have particles made up of just 2 quarks, or more specifically, a quark and antiquark pair. These particles are called mesons. Binding quarks together inside mesons, protons, and neutrons are gluons, which carry the strong nuclear force. Now, here's some shocking news. The strong force is strong. So strong that an isolated quark has never been observed because they seem to be locked inside protons and neutrons in all but the most extreme conditions. Now we come to the mystery of the X particle. We think it's made up of 4 quarks, but nobody has been able to figure out yet how they're arranged. The 2 leading ideas suggest either the 4 quarks are tightly bound up in a teeny space less than 1/3 of a femtometer across, or they could be paired up in 2 mesons that form something like a molecule that's loosely bound and as large as 5 femtometers. For reference, we think a proton has a radius of about 0.84 femtometers. This is where the Large Hadron Collider comes in. The LHC was not the first accelerator to spot the X particle. It was actually first seen almost 2 decades ago by the Bell collaboration in Japan. But until now, all the experiments that have spotted it were either smashing together electrons and positrons, protons and antiprotons, or protons and protons. Scientists think the key to unraveling the X particle's secrets could be recreating conditions like those just after the Big Bang. That isn't easy to do by smashing protons together, even at very high energies. Now, you may be wondering why the LHC is different, because as you may know, the LHC also smashes protons together. Famously, that's how it found the Higgs boson, often known as the God particle, but don't call it that in front of physicists. It turns out most of them hate that name. However, for part of each year, the LHC stops smashing protons together and instead sends something much heavier hurtling around its enormous ring: lead. When 2 lead ions collide inside the LHC, hundreds of protons and neutrons are slammed together in an instant and heat up to over 2 trillion degrees. That's 100,000 times the temperature inside the core of the sun. It's so hot, I didn't have to say if it was in Celsius, Kelvin, or Fahrenheit, because I mean, does it matter at that point? Above that threshold, the quarks and gluons normally bound up inside the protons and neutrons can break their bonds and create what's called a quark-gluon plasma. We think the entire universe was in a quark-gluon plasma state for a few millionths of a second after the Big Bang, allowing exotic matter like X particles to form and decay again until things started cooling off and particles like protons and neutrons formed. When researchers at the LHC started looking for X particles produced by lead ion collisions, they weren't sure if recreating this primeval particle soup would help them or hinder them, because it would also generate tons of other particles that might mask their presence. There's also the problem that X particles decay so fast the particle itself can't be detected, only what it decays into. Using machine learning algorithms to sniff out the telltale signs of decaying X particles, they were able to identify about 100. Just 100 from more than 13 billion collisions. Doesn't sound like very many, because it isn't, but with this method, X particles were detected about 10 times more frequently than in proton-proton collisions. Spotting more X particles in conditions similar to how they formed in nature can finally tell us what they're made of. If they decay very quickly, then that would point to them being loosely bound meson molecules. If they decay still really quickly, but slightly less so, then they're probably made of 4 tightly bound quarks. Unfortunately, the 100 seen by the LHC aren't enough to definitively point to one possibility or the other. But now that we know how to spot them in a quark-gluon plasma, scientists are ready to hunt for a lot more. The LHC has been undergoing upgrades since 2018, but it's gearing up for another run. Heavy ion smashing is scheduled for November of 2022, and after scientists have a chance to sift through the data, they may see enough X particles to finally solve the mystery of their makeup and give them a name once and for all. I hope they go with Julian. That's a good name. If you enjoyed this quick dip into the warm waters of fundamental particles, I've got great news. I made a 3-part deep dive on our other channel, Seeker Plus, all about the Higgs boson. I think it makes understanding particle physics surprisingly approachable, and I am so proud of it. So do me a favor, go check it out. In the meantime, though, place your bets. Do you think the X particle is a tetraquark or 2 mesons? Let us know down in the comments section, and be sure to subscribe to Seeker. Until next time, thanks so much for watching.